Okay, thank you very much for sticking around until so late. Before I start, let me just say, please interrupt me anytime for questions, especially clarifying questions. As an introduction, okay, let me just bring back stuff that has been said already, but it will be helpful for explaining then what I do. And let me talk about the relationship between blockchain and tokens, okay? Now, we heard earlier, especially in the first keynote, the distinction between private and public blockchain, okay? In a private blockchain, the participation into the blockchain, participation into the network is regulated by some sort of authority. It could be a consortium, could be a large firms. For example, it could be a blockchain a system aimed to keep track of item flow in a supply chain. And in this case, for example, the Walmart, so the biggest player in the supply chain, is the regulating entity that determines who get to participate into this blockchain. Now, there are no tokens typically in private blockchain. And the reason is that the incentives for doing all the things required for the blockchain to work can be given by this outside organization that also regulate entry. So it will establish that, okay, you and you firms participate into this blockchain. You also put some computing power to participate into the network and update the ledger as it is required. Now, things are different for public blockchain, those which anybody can join and participate, okay? Because here a problem emerges. So for the blockchain, for the protocol, for the network to function, things need to happen. People need to do stuff that can be costly. So how do I reward people for doing those things? And here is where the token come in, because the protocol in itself can specify that if some people perform this and these other actions that are useful for the running of the network, they will be awarded tokens. And so here is a world where the public blockchain is very much closely intertwined to tokens, because otherwise it wouldn't be clear how you can provide incentive for people to participate in this network and the network ultimately to function. And finally, there are, as Andrea was discussing, and also the previous talk was related, tokens as contracts. So I could be a bakery, okay, and I could issue a token. This token will be transacted on a blockchain system, but it could represent, for example, a voucher. So it could be a baguette. If I show up with this token to the baker, I get a baguette. Or it could represent a claim on this business profits, on this business revenue, or a combination of pre-sale of output and revenue, okay? But the important thing here is that the business itself doesn't need to have anything to do with blockchain. It can be any regular business. Where the token and the blockchain come in is just the way these securities, if you want, end up being traded, okay? And currently, I think token and contract could be potentially extremely relevant in the future, because they are instruments that can be relevant to any business, not just blockchain-based business. And so, for example, everything to do with security tokens, so on and so forth, will fall in that category. But for the moment, most of the action is on public blockchain, okay? So for example, the biggest ICOs are tokens associated to public blockchain. Or if you go to CoinMarketCap and look at the most valuable tokens or the entire crypto market, about 90%, and I stopped at 90% because I got bored, but if you go and count, more than 90% of the value there correspond to tokens associated to public blockchain. So although that part is, to me, will become extremely relevant in the future, for the moment, quantitatively, the public blockchain is, the token associated with public blockchain is the most important phenomenon. And if you want to study token associated to public blockchain, we have to start thinking about what is the role of token, and I think in what I want to discuss later, there will be three. The first one is that, as I said, tokens are used to reward the participant to the network. Now, in the model I show you later, this won't be explicitly modeled, but it will be there to justify why we have the token, okay? And it's not explicitly modeled because exactly how token end up rewarding participant to the network is very contingent specific to this or this other blockchain-based protocol. It's different in Bitcoin, it's different in Ethereum, it's different in Steemit, it's different in MakerDAO, it's different. But it will serve as a justification for the existence of the token. Now, once I have the token, I can use the sale of this token for raising financing to then develop the protocol. And this will be the ICO, okay? And this is where a lot of the literature has focused its attention, okay? So you selling token to raise funds. But there is a third aspect that is what has been so far overlooked, Okay, that those tokens are also the mean by which, as a developer of these protocols, I also gonna earn profit. Okay, so this is basically what I call seigniorage, because it's not new, but it's new in this context. I can make money by selling tokens. Okay, and the goal of this paper, the project, is to basically to study theoretical these two aspects of tokens. So these two uses of tokens. So I can sell tokens to raise funds. That would be the ICO, or I can sell token in the end to also earn a profit, and this would be seigniorage, and that is what is new. Actually, when I wrote the paper and put it up, this was the novelty with respect to the literature. Now there is the paper in the by Will, the last keynote. The last part had an element of this, in a sense that the platform owner was also deciding on the inflation rate, and this was explicitly accounted in its profit. So now, for example, that paper also has an element of this seigniorage. What remains true is that so far mine is the only paper that look at these two aspects and try to compare and see how it works when one is present or not. I'll see you later. Now the emphasis is going to be on the incentive of developing this blockchain-based protocol. For computer scientists here, let's think about the incentive to create the code, fix bugs, do commit on GitHub so that the code works better and faster and becomes finally something that people can use on a large scale. And just to give you a preview of results, to give you an idea where I'm going. As with also previous paper was pointed out, as with many ways, so as often happens when I have external financing, using external financing weakens incentives. Okay, if I'm using someone else's money to do something, I have less incentive to work hard and do stuff than if I was using my own money. So this is universal principle, almost universal principle. What is going to be so, and this happens also in the model. What's going to be interesting is the specific forms that this weakening of incentives takes, and I will show you that if an entrepreneur runs an ICO, in all subsequent periods, there is a positive probability that he's going to just sell all his token and stop developing the protocol. Okay, so it's this sort of token dumping that turns out to be the equilibrium of the model. Okay, so in this aspect, the specificity of weakening incentive is new to this setup. But maybe even more interesting, even if I'm assuming that the developer is deep-pocketed, so he does not need to sell tokens to raise funds, so he does not need to go through an ICO, the equilibrium of the game will be inefficient for the following reasons: that it turns out that the developer's payoff depends on the usage of the protocol in the moment where he plans to sell his token, so in a specific period. But this protocol will generate benefits over multiple periods, okay? And so basically, this will be completely disregarded by the developer. So it's as if the developer's payoff depends only on a specific time period, while the social benefit of the protocol is generated over multiple periods, okay? Now, interestingly, but for this I need to show the model, it may still be the case that the developer overinvests. So there is inefficient in the sense that too much investment and too much effort. Or the other case, depending on the parameter. But this I need the full setup to show to you. Literature. So since most of the authors are here, I won't embarrass myself in trying to summarize each paper with 2 words, because A, you will hear the full presentation of some of them, and B, of course, I can do just a lousy job compared to what I can do. Let me just say that, of course, the one of the 2 cases I had earlier, token as construct, there is a literature studying this, and the first paper presented in this session clearly falls into this case. I will put the second one also in this case, but then listening to the presentation, maybe the author will disagree with me here. There is also a literature that studies more specifically what I'm interested in, that is tokens that are linked to blockchain-based protocols. This would be, for example, the previous keynote presentation. Interestingly enough, most of the literature has studied how tokens the existence of token interact with the multiplicity of equilibria that you have when you have network externalities. Okay, so either in what was discussed earlier, this idea that now we have also intertemporal network externality in addition to each period network externality more classical that exists in each period, or papers looking how you can sell token at ICO in order to achieve one or the other equilibrium. So the fact that token can be used to achieve a high adoption equilibrium maybe should have been one of the a fourth use of tokens in public blockchain that I didn't have in my first slide. And I didn't have it because it will not be part of the model, so it was a bit self-serving. But it is also a reason why tokens play a role in public blockchain. And finally, there is a paper by that was also discussed in the keynote by Will. In the last part, where again the platform developer is creating money and selling token, and this generates a profit, which is exactly this seigniorage I was discussing about. Okay. And there are many differences in the way I model stuff and they model stuff that gives rise to many differences in the results. But because I haven't shown you my result yet, it would be pointless to me to start discussing that. But it's an interesting discussion maybe we'll have over dinner, I don't know, later. Okay, so let me show you the model. The main character of the story is a developer who is alive between period 1 and capital T. And the fact that there is sort of exogenous period where this guy leaves the game is the main assumption. You may not like it, but it simplifies tremendously, and so I think it's an assumption worth making. Now, this guy is building a blockchain-based protocol. This could be building Ethereum. This could be building EOS. This could be building Steemit. This could be building any of those protocols that we heard discussing today. And he initially holds the total stock of token. Okay, M, and I'm abstracting away from inflation, so the stock of token is fixed. Now, what happened? In each period, well, at the beginning, he will own some tokens and some assets. So think of this asset as cash. And then what he does is going to exert a certain amount of effort, so he's going to work very hard, and he's also going to invest into the development of the protocol, where the assumption is that he cannot invest more than the cash he has available, the asset he has available. So there is the cash constraint. And his objective is to maximize his asset at the end of period T. So he wants to maximize the cash he has when he leaves the game. And now the model is engineered around the following fact, that the developer may need to, so he's going to be, by assumption, token abundant, but maybe cash scarce. Okay? And so he may need to exchange some token for cash, either to then invest in the protocol, in the development of the protocol, or just to eat it, okay? And this selling token for cash can happen in two moments. One is at ICO, so in a given period that I call T0, which is chosen by the developer. So here is also an interesting difference with what has been done earlier. Here is the timing of the ICO is endogenous and it's chosen by the developer. The guy will run the ICO, and the ICO here is simply modeled as an auction. So he's going to decide, I'm going to auction out this many tokens, okay? And so, and by assumption, before the ICO, he's forced to hold the entire stock of tokens. So QT, for any T before the ICO, must be the entire stock of token. And finally, in every post-ICO period, so after he has the ICO, there's going to be a market for token that creates in every period, in which investors will buy and sell tokens, and he also can participate into this market and buy and sell token, okay? And this again can be done for raising additional funds to invest into the development of the protocol, or to get cash to eat it before leaving the game. Okay, so there are these two moments we can sell tokens. Finally, there are users. Here, users are very stylized in the sense that they will, the assumption is that so when the developer exits the game, users start using the platform, or the decentralized platform, the protocol. And they will use it to exchange goods or services of a value that depends on the entire sequence of effort and investment put in by the developer in the previous capital T periods. Okay. Now, you may notice in my interpretation of the model that I am somewhat interpreting this protocol as a decentralized marketplace, okay, which is the most natural interpretation, but you can think of this in other ways. And in that case, V will be a measure of usage, okay, but that will depend specifically, so it will still be a function of effort and investment, but may not be exactly equal to the value transacted. And finally, there are investors that are assumed to be risk neutral, price takers, forward-looking and cash abundant, okay? So they will buy tokens from the developers at ICO, And in every post-ICO period, they will buy and sell tokens on a frictionless market for token. And this summarizes the model. If some things weren't clear before, maybe they will be clear now. So there is a pre-ICO period where the only thing that happens is that the developer puts effort and invests into the development of the protocol. Then there is the ICO. The timing of the ICO is chosen endogenously by the developer. And again, effort and investment, but then the new thing is that there is this auction for tokens. Then there are all this post-ICO period, in which again, effort and investment, but now there is a market for token, so tokens are being traded. Then a period capital T, the developer exits the game. And at that point, we have user coming in, and in every period we have a market for token that opens, and user using the protocol to exchange stuff. And this goes on indefinitely, so this is used with no end in sight, which what gives value to the token, because now otherwise, okay, there's a problem with value of money with finite time period, but this is not the case here. Assumption. Because development stops in period capital T when the developer exits, the price of the token will be constant from capital T onward. But this then creates an indeterminacy, because the return for an investor, the return of holding tokens and the return of holding cash is the same. So there is an indifference. So if I'm an investor, I could hold cash or I could hold a token, and this will give me the same return because the price of the token is constant. How do I get around this indeterminacy? I'm simply going to assume that a fraction gamma of the total stock of token will be in the pocket of investors from capital T onward. Okay. Now this leaves 1 minus gamma fraction of the token, so 1 minus gamma times M tokens for users to exchange using the protocol. Okay. Now, if in addition I normalize the velocity of the token, so the number of time in which each user can go on the market and buy a new token in every period to only 1, then I can write down a price for the token that applies to period capital T onward, okay? Which is simply the total amount of value that needs to be exchanged on this protocol divided by the number of tokens available to users, okay? Now, what is important, so this is one of the most widely used pricing logic for these tokens, okay? And it's simple and I use it here. What is going to be important is that the price of the token from capital T onward is increasing in the sequence of effort and investment made by the developer. So the more the guy works, the better is the protocol, the higher is going to be the price. Now, therefore, you could have a more complicated model, and my results will still go through. Okay, this pricing formula is very convenient, but the result I'm going to show you again won't depend on the specifics. It's just that the price needs to be increasing in the effort and the investment. So, for example, I know Julian doesn't like it, but I'm sure it will go through with whatever assumption he likes. There is full information, so this is not a model where there is moral hazard, where people or there are no scams, there is no people that go out to try to, everybody knows everything in this model. And there is no discounting, so neither the developer nor the investor discount the future. Okay, simplifies the derivation of the equilibrium.
So we should think of this as a world in which the Modigliani and Miller theorem applies.
No, because I'm constrained by the only source of profits are the tokens. Why not an answer? Yes. There's
no asymmetric information, no imperfection, no strategic behavior, financial structure.
No, but I'm putting a constraint, so it doesn't apply, not because there is no full information, but because there is no perfect contracting. So for example, okay, the model has an extension, for example, where I introduce an external financier, a VC. And the VC, the assumption is gonna give money under the promise that you're gonna deliver some tokens in capital P or capital T.
So what is the friction?
The friction is that the only profits here come from the fact that you're gonna sell some token. And there is a pricing formula for those tokens. It's not a contract, it's just your token times the price at which you're gonna sell it, and the price is this one. I'm not writing a contract. And that's actually the difference also with the literature looking at tokens as contract. That's not what I'm doing. And the price at which I can sell it depends on the usage of my protocol. So this is about what is the payoff of the guy working on Ethereum. Like, they sit on a stock of Ether, they are progressive in selling it, part is used to finance their operation, part is profit for them. But there is no contract with anybody. I mean, okay. So if you want, this is a constraint on the contracting space. Okay, so as I said, the goal here is to compare two ways in which, two roles of tokens, right? As a mean of raising funds, as a mean of earning a profit. In order to do that, let me start by shutting down one of the two channels and say the developer is rich. So the developer is deep-pocketed, so he does not need to sell token in order to invest efficiently in every period. Okay, and let me look at what happened in that case. Then I'll bring back the need for potentially selling token to get financing. So the main result is that if the developer decides to do an ICO, in every subsequent period, the equilibrium will be in mixed strategies for the following reason. Because investors are forward-looking. So if investors expect the developer to work hard on the protocol and do a lot of improvement and make it great, this should reflect on today's price. Okay, the price today should be already high. Now, but if this is the case, the developer can essentially cash in for on his work without actually doing any work. Okay, he's just selling his tokens so to benefit from his work, but before he actually does any work. Okay. On the other hand, if investor expect no work, the developer should just keep all his token, work hard, and sell tokens in the following period. So there is an anti-coordination problem in this game theory jargon, if you want. And the only equilibrium in this case is one in mixed strategies, in which, with some probabilities, the developer will sell all his token on the market, or with some probability, he is gonna just keep his entire stock of token. Okay. These are the two possible points that he's randomizing over. Now, given this, you can ask yourself, when is it optimal to hold an ICO? Well, basically because the developer does not need the money and the ICO will weaken the incentive in this specific way, he does not want to hold the ICO until the very last period. So basically he's just selling all this token in the last period, could be period T or T-1, but basically he's holding on to his token until the very last period, then he sells everything before leaving the game, okay? Now you may ask yourself, is this efficient? It turns out it's not efficient, okay? For the following reason, because given this, the level of effort and investment put by the developer is trying to maximize M times PT, so stock of token times the price at which he's gonna sell this token, which is given by VT, so the total volume of transaction on the protocol, divided by Y minus gamma, which is the share of token not in the pocket of investor, but rather available to user to be used. Now, in truth, in the first best, this investment and effort should be set to maximize the present discounted value of the surplus generated by the protocol. Now, a bit of approximation here, because I could interpret VT also as a measure of welfare, okay? It doesn't have to be, but let's say VT is also a measure of welfare generated in each period, okay? Then the objective function from the first best should be this VT divided by 1 minus beta, where beta is the consumer's discount factor. So under this approximation, the guy is over-investing or under-investing in developing this protocol depending on whether gamma is greater or smaller than beta. So whether the fraction of tokens held by investors and not used to trade is larger or smaller than the discount factor. And one could, so for fun, if you want, what I did is to look at data from Ethereum and try to estimate gamma or beta. You set it to 0.05, so 5% per year, and then you want to look at gamma. Okay. Now, of course, this is imperfect because the model, this should be about the fraction of token held in the long run, so when the development is finished, okay? This is clearly not the case for any of these blockchain-based protocol. But as an exercise, one can look at what is the gamma for Ethereum, and it's much larger than beta. And that's because the vast majority of tokens are kept stuck, okay, by investors, and only very tiny fractions circulate and is paid in fees in every period, okay? So this will suggest that the relevant case here is the overinvestment case. Now, okay, I'm a bit running out of time, but if you introduce a poor developer, so now you have also the ICO before capital T in equilibrium, and therefore there is the possibility that the guy is gonna exactly dump his token on the market. There is also another result, but I'm a bit short of time, in which you have multiple equilibria. And the reason is that here what happens is that if the investor expects a high price, okay, I need to sell only a few tokens in order to meet the requirement in order for them invest into my protocol, which means I get to keep a lot of token, and then I'm gonna work hard because I still have a lot of tokens, which justify the high price. But if instead there is a low price, if I want to meet my required cash to invest, I need to sell a lot of token, but this is gonna weaken my incentive because I'm left with few tokens, which means I won't work very hard, which means price is justified to be low. So there is in addition, coordination problem between investors and developer that generate multiple equilibria. Okay, but this is a bit an interesting side result since I'm running out of time. Okay. Therefore, the so holding an ICO allows you to get the funds to invest, but in subsequent period you may dump all your tokens. So there is this weakening of incentive, and then there is this trade-off between when you want to hold your ICO. Okay, so I think I have what? Okay, 2 minutes. A couple of final considerations. In the paper, I spent a lot of time discussing the relationship between, so why are those protocols all open source, okay? And the thing is interesting, I think, in two ways. First of all, normally open source software, the developer behind open source software don't get paid anything, okay, directly for their work, okay? And this is why most open source software, despite being very important, for example, the internet, so on and so forth, is lacking investment. Okay, but this here is a case where you can develop open source software and still gets a lot of financial reward from it. Okay, not only, but there is a sense in which if you want to benefit from seigniorage, it better be open source. In fact, I don't think there is an example of non-open source blockchain-based protocol successful, at least. And that's because I think people need to see on your code some rules about how many tokens are created, something about the monetary policy, so on and so forth, so that you can credibly commit in front of them, and they're gonna then buy your token, believing that there won't be just, you won't multiply by 100 the supply of token in the future. So there is the idea that blockchain plus open source can be used to create commitment on the monetary side. Now, you may have spotted a weird feature of the model, because in equilibrium, in the model, you have that investors are left indifferent, because cash gives the same return as the token, so they are indifferent between holding token and cash in equilibrium. Now, users will earn the full surplus generated by the creation of the protocol. There are no fees or nothing, so the surplus is fully earned by the users, and despite this, developers are strictly better off, they earn the profit. So if you take it this way, there's something doesn't add up, because it's not clear where the developers' profit are coming from. And this is a feature of the fact that we're in a partial equilibrium. So I am fixing the price, the economy-wide price level to constant. Okay. Now, the general equilibrium version of this will have the fact that I am, in fact, creating a new stock of money, and this new stock of money adds to the existing stock of money, although it's in different forms, I can still add everything. And therefore, now that I expand the stock of money, I should change the price level. So this generates inflation. And in that model, the developers' profit are exactly equal to the inflation generated in the economy. And there are obviously profits. Huh? You have a question? So, okay, that's why. So that's why I leave it out from the model, because for the moment it's a little bit so it's science fiction for now to think that the developer effort has an effect on inflation. But who knows? Maybe in the future, central banks will look at the commit on the GitHub of Ethereum and adjust their monetary policies on that, because as the thing improves, they expect more people to use it and therefore higher inflation. So it's a side note, because obviously for the moment we can just forget about it. But it helps to explain the mechanics of the model to some extent. But there are models that are trying to look at this monetary equilibrium, where you have this new cryptocurrency that come in, Bitcoin 1, Bitcoin 2, or Linda has a paper as well, presented tomorrow. And I think so why this is interesting, because you could, for example, use this model, start thinking about free entry of competitors. We have multiple cryptocurrency, like zillions of cryptocurrency. We have multiple decentralized computing platforms, such as Ethereum, and then EOS, and then this, and this, and this, that. Now you need a model such as this one that explicitly models the profits of the developers, and how this depends on the tokens that they can sell at what price, to understand this extensive margin. Because of course each cryptocurrency token has finite supply on the intensive margin. So each of them has a finite supply by virtue of blockchain. But on the extensive margin, how many of those we can have, well, there is no real reason why it should be finite. But you need a model to study whether and to what condition the monetary supply on the extensive side behaves. Okay, done. Thank you.
I have a quick question.
Okay.
So, when you talk to developers, they are very concerned about when they have open source blockchain that they might be cloned, and people will clone them and not use their token because it will be cheaper for their users.
To use an alternative token.
Yeah, to use the same technology but without a token. I mean, just like I'm cloning your open source platform and then I'll make it accessible to people who don't need the token. So where does that fit in your model? Because
so this will definitely fit in the extension I'm working right now, and hopefully we'll be ready soon. It's still going to be the case that if you want to monetize via this mechanism, this seigniorage, that your profit comes from eventually selling your stock of token, it will have to be open source. But now the equilibrium in a world where you can create this multiple, that's why I think it's an interesting question. The facility with which you can create competitors is unprecedented, because here you can just fork everything and create Ethereum Classic or whatever. But hopefully this will be something that I can answer in this case. Yes, it's coming, it's coming. Stay tuned on my website. Follow me on Facebook.
Thank you for an excellent presentation. My name is Peder.
Okay.
Here. I'm just wondering, I'm not sure if I got what you said about contracts, if it should be contracts or not contracts, because I would guess that contracts are very important here to limit liability and make the model work, because if you are not specifying a limited liability in a contract, the developers will be subject to some fiduciary duties or contract law, and they will have some, so to say, external restraints or incentives outside the system, because they can be legally liable if they don't do as the purchasers expect or something?
Well, okay, so it's not a contract, because if it's not a contract, this goes back, so for example, there is this recent opinion by the SEC discussing when should we think of this token as securities and when should we not think about security. And they explicitly said, I don't know if it's in that specific or some, that they don't think of Ethereum as a security. And the criteria is, well, an Ether is an object that you need if you need to operate a protocol. Now, if all the Ethereum guys would run to the Bahamas tomorrow, the whole thing will still have a value, because the network will still function and you'll still. So it does not depend on an expectation of work on other people having positive value. So this is not a contract. Okay, this is exactly what I'm trying to model. So a token that is not a contract is rather an object that is necessary in order to operate a protocol. Now, as I showed you, it does come with a drawback, because in equilibrium, those guys may dump all their token. But that's, so in some sense, that goes also to Bruno's point. So it's not a contract. Okay.